Why does calculus remain the subject mathematicians most love to hate? Part of it is the historical terror of the infinite, the unease that comes when you imagine a number dividing into infinitely smaller and smaller pieces. In 1734, Bishop Berkeley critiqued infinitesimals, values approaching zero without reaching it. He rejected infinitely small quantities, branding them ghosts of departed quantities. This historical panic points to a deeper struggle. The human mind often buckles when asked to comprehend a world of continuous, infinite change. Fast forward to the present day. Modern computing has effectively automated the heavy lifting of these calculations. Yet we still require students to carry 1,000-page textbooks and memorize algorithms that machines can process in a fraction of a second. It raises a difficult question. Is learning these formulas by hand still a prerequisite for understanding the digital logic that now runs our world? Or have the discrete digital steps of the computer finally made the agonizing analog formulas of the past irrelevant? What if our understanding of the universe relies on stripping away the academic jargon that makes high-level math feel inaccessible? In 1910, an electrical engineer named Sylvanus Thompson challenged the entire mathematical establishment. He published a radical manual called Calculus Made Easy, built on the belief that math should be democratized. Thompson's core philosophy was simple. What one fool can do, another can. It suggests that intuitive explanations, rather than rigid memorization, might be enough to demystify even the most terrifying concepts. When you look past the proofs and the jargon, you start to see this mathematics working in every corner of the real world. A video game physics engine uses differential equations to simulate gravity and handle the split-second collisions between virtual objects. In medicine, these same principles allow scientists to predict exactly how drug concentrations will rise and fall in a patient's bloodstream over time. Structural engineers use integral calculus to ensure a suspension bridge can handle the weight of thousands of cars across varying conditions. This diagram shows gradient descent. It's the logic driving machine learning algorithms, using derivatives to find the most efficient path to a solution. This system is our best method for tracking how the world moves, flows, and evolves in real time. In a world of digital tools, the priority for a student might no longer be the calculation itself, but the logic behind it. Offloading the computational work to a machine allows the human brain to focus on the broader implications of the math. Paradoxically, the computer might be the very thing that allows us to finally appreciate the intuitive philosophy of change that Sylvanus Thompson championed. By translating smooth motion into discrete digital steps, the machine handles the complexity so we can understand the principles. The goal is to move from memorizing a nightmare of formulas to recognizing the mathematics of continuous change in our daily lives. If the universe exists in a constant, magical state of flux, this logic provides our best way to map that change. Maybe it's time to join the fools who finally learn